Today, we're going to have another brilliant young woman, Aziza. Aziza will be sharing with us an extremely valuable insight of effectively utilizing LLMs to combat its very much correlated stigma of ineffectiveness. She leads us to ask the question, are we contributing to the errors that we see LLMs run into? And without further ado, please.
Hello. Hey, everyone. I'm Aziza, and I work as applied scientist at Oracle. So in our org, AI science, we try to bridge the gap between the product development as well as the AI research. And these are just the learnings that I learned through conducting AI evaluation of the state-of-the-art models. And today we'll be discussing about the prompt variation and how it can be used as a diagnostic tool, exposing us about like data contamination, some of the model memorization, and how we can actually understand the true capability of LLMs. So we query LLMs through, we basically prompt the LLMs through query, or we provide we request like instructions from LLMs, right? And of course, when we get the response, we want the performance to be pretty high, right? So, but across different evaluation, if we see a 95 accuracy, and sometimes if this 95 accuracy drops into, like, let's say 75, isn't just the random, right? So it's quite alarming. So it's actually telling some story for us. And this story could be like that prompt brittleness problem in LLMs. So what does actually prompt brittleness problem means? So it means that LLMs are sensitive to prompts they receive. Like, for instance, if there is any changes in format or styles or structures or orders and more, LLMs they get quite like hallucinated or just a bit sensitive about them. Like, for instance, minor alterations in format, instructions, they can trigger a substantial influence in LLM performance and can lead to significant variation in LLM output. And of course, this just lead to misjudging a true ability of LLMs, especially like we want the output to be quite deterministic, but these LLM models are non-deterministic, right? They might always provide a different answer all the time, but how we can actually like structure them and ask them to give a similar constant answer all the time. So models that break under small paraphrases will likely fail in real-world user-facing application where phrasing is unpredictable. For instance, like I'm talking about like if you go to ChatGPT and we are like in a hurry, sometimes we just ask something and we don't even pay attention to the letters. Are we actually typing your correct letters? Are we having some spaces, or is it a capital or lower letter? So how can we ensure that these LLM models are robust enough for this kind of changes when we query them? So some of the research that came out recently, it's from Microsoft, like does prompt formatting have any impact on LLM performance? So they evaluated 4 templates across, like 4 templates across different tasks for GPT models, and they found that the GPT-3 Turbo has 40% shift due to prompt template formatting. So for instance, as you can see in this visual, in the first performance accuracy was around 35% for markdown template. However, if we shift to JSON, we can see like 40% shift. We are getting much more higher accuracy if we have a JSON template, and it's quite alarming, right? So, but they found one thing that this could be not specifically for for all different models. Of course, it differs depending on the model sizes, but most of the models that are like a smaller size, like a GPT-3.5 Turbo, could actually get impacted. They also found that prompt formatting significantly impacts LLM model performance with no single format consistently excelling across tasks, which means it doesn't matter if it's a big size model or small size model, we can just take one single format and say this is going to work universally for all model families and model sizes and all different kind of tasks. So this leads to our learning one, which rather than static prompts, use a diverse prompt formats and LLM evaluation to accurately understand, assess their performance. So let's just take one example. Everyone might be familiar with the GMS 8K benchmark. This is a math reasoning benchmark. It's quite famous, and it's actually utilizes in majority of the SOTA model evaluations. And it's actually been contaminated quite a while, and because it's been a couple years that this paper came out from OpenAI, and right now, if you maybe Google GSM8K, there's a multiple different variation of the same benchmark because, of course, like researchers, they're developing more like a different variant of the same math reasoning benchmark. So let's just take one example. From the GSM8K style problem. It's not from there, it's just an example. It should be similar to like our 8th grade student math problem. Like for instance, Lime has 48 marbles, he gives 1/3 of them to Noah, and then wins 18 more in a game. How many marbles does he have now? So obviously ground truth is 50. So if we apply, let's say, a lexical semantic variance into it, we can change some parts of it. For instance, parts with a 1/3, later gains 18, and of course we add something like determine his final count and explain briefly, right? So what we probe here, so we just want the model to understand whether the model preserves answers and their wording changes with identical intent. So we want the semantics to be the same, and we want the answers, we want to have the same answers at the end, right? Just change up some phrases. Another variation we can add is the structural variation. It's for instance, here, as you can see, we add JSON, but we add the JSON type specifically inside the query, not like as a template. So here, we just want the remain after give X as well as the final answer in JSON format. So this one basically tests the model's reliance on output schema and wrapper templates. For instance, here we are testing plain text versus JSON, bullet versus prose, or we can also change the role versus system or the headers. Another thing that I've seen like some researchers, they've tried in structural variation is add persona. So we can, of course, query LLM to pretend to be some kind of persona based on specific problems that we are giving. For example, for this specific problem, we can say, pretend you're an 8th grade student or something similar. So another variation that we can add and test the model is we can test the model's order sensitivity. And sometimes when we prompt the model, we give them a few shot demonstrations, right? But most of the shot demonstrations, it might be quite similar, but we need to ensure that they're quite differ. They may have differ, but we can ensure that they're quite similar in terms of the steps that the query takes. So here in order sensitivity, we are specifically testing and querying the prompt first following the same order. For instance, we have demonstration 1 and demonstration 2 second. In the prompt F, we kind of reverse it. We have demonstration 2 and then demonstration 1. So here we are just testing the model's context integration, as well as testing its recency position bias, like how, for instance, if we have benchmark, we want to ensure that the model is not memorized this benchmark, especially the order, that it could be, we are testing if it's robust enough for different sort of positions, especially in context learning. And another variation that we can integrate is reasoning variation. You might be familiar with the COT, which is a chain of thought learning that we integrate typically in reasoning. So here we can, at first, we can integrate COT reasoning first, which asks the model to provide like step-by-step explanation of the whole problem. Basically, we request the model to chunk the problem into smaller steps and make it easy for the model to understand. And another one is here we are adding some confusion. So we are adding fraction confusion, and we are saying that this is the wrong answer. Another one is we are also doing reverse order logic. So here we are just starting from like he wins 18, so now he has 16, then gives 1/3 away. Except the original of the question that we had was he gives third of the way the second. 1/3 of them to Noah. It's in the second step, right? But we basically reverse order and made it as a third step. So this way, we're basically testing the model stability of internal reasoning. Because sometimes, like if the model is not a reasoning model, I know like reasoning models are quite expensive, meaning, and they're quite slow sometimes. But if we use like a general task model and we want them to behave as a reasoning model, we may not be able to trace their reasoning, right? So by integrating this sort of reasoning variation and like a multi-path COT, we can better understand like their stability and how consistent they are in terms of understanding the whole query, and that they are not actually remembering from their internal knowledge, but actually reasoning through the questions. And so that can just lead to our question, do diverse chains converge on the same conclusion? Meaning like if we just change and reverse order logic, are we getting the same answer as well as just not doing that? So, and another example is from this paper. It's called like the mixture of formats. The authors basically they test the LLM's exposure to diverse data points, and they found that they help the models to deassociate the styles from target variable. For example, in a traditional prompt, if you have all the same like input and output, the mixture of format prompts might be quite different. The main thing that they change is some of the names. For instance, previously we had input, then we changed to question, output changes to answer. So, and they have like around thousands of different variation of this. So basically, instead of using the same format style for all few-shot examples, use a different style for each example in the prompt. So what they found is that the LLMs decorrelate the style from content. That way, model learns that format style is irrelevant to the task, and it helps to diverse exposure, meaning seeing multiple formats during few-shot learning makes the model less dependent on any single style, because that's what we want, right? We don't want them to be dependent on the style itself. We want them to actually reason through the task. And the main one is the explicit rewriting instruction. So it reinforces that different format expresses the same information and leads to the same output. So their setup was like they evaluated across 16 tasks in the supernatural instruction benchmark. I mean, if you're familiar with this benchmark, it includes quite a different tasks, like starting from like classification, summarization, and they mainly evaluated on like open source models. And the metrics that they evaluated on is the spread. The spread is quite widely used measurement technique to measure the prompt burdeness. Basically, if you have a large set of prompts, what we do is that we get the max accuracy of the prompts that we have seen, and then we get the min accuracy of the prompts that we have seen, and then this way we get the spread, which means that the lower spread it means that the model is robust to prompt changes. If it's otherwise, the model is not robust to prompt changes. And of course, the comparison that they do is between the traditional prompts and the mixture of format prompts. And some of the observations that I just took from them is that, for instance, in classification tasks, as you can see here, we have quite a lower spread, which means the model is robust enough, and then it's good that the min accuracy And max accuracy, there's not a big variation in between, so which means that like this specific model is performing good. Similarly with the stereotype detection here, it's actually inverse with the stereotype detection here. As you can see, min accuracy is quite low, but max accuracy is quite high. So that means that the model may not be quite robust enough to the different variants. Yeah, so this leads to our second learning, that in LLM evaluation, it's less about getting a higher accuracy and more about probing the stability and reasoning generalization. Because the model needs to grasp the underlying semantic of a task, and that can actually help to lead more stable performance across different changes. Especially when we are working not only at one agent but multi-agent scenario, we want the LLMs to be more constant and stable in performances. And so that leads to our main part, that prompt variation can be used as a contamination detector as well. So what do I mean about data contamination? It's when evaluation benchmarks leak into training data, and models' high accuracy may reflect recall instead of generalization. For instance, right now, like whenever a new model comes up, of course, a majority of them, they use similar benchmarks, right, to evaluate their LLM. And of course, there's a higher chance that those benchmarks might have been, that those specific models might have been already contaminated of those benchmarks that they're actually using and showcasing to the world about their performances. That's why we need to ensure that when the new model comes in, and we need to understand if those models are not contaminated, and whenever we evaluate them on a benchmarks, we need to ensure that they are test cases that models doesn't have a knowledge of. So memorize the original phrasing and pattern matching fails to answer the response correctly, and the genuine understand that models need to genuinely understand the task, and they should handle the rephrase prompt with minimal performance drop. And yeah, so prompt variations, the techniques that we have just seen, they can help us to unmask the training data memorization. So how can we actually detect and mitigate the training data contamination? So one of the ways that we can do is stress tests with prompt variation. We can utilize the similar techniques that we have discussed. For instance, like rephrasing, or applying some lexical semantic variation techniques that we have utilized to the same benchmarks, but create a different variant of it. We can shuffle them because, for instance, there was a case that the multilingual data benchmark apparently have been 60. I don't have a specific, I can't remember the specific percentage, but we found that MGSM, it's one of the multilingual data set, that it's been contaminated. So one of the way that what we tried is we just shuffled them, we changed the order, and that also kind of gave us completely different performance than what we used to get. So another thing we can do is just reformat the benchmark prompts. That could be the most, these three techniques could be much more a faster way to strut test the benchmarks. And if we have a big drop, it means it's memorized. Another thing is, using contamination-free benchmarks. We can employ paraphrased or newly generated sets. As what I was saying is that we can just take the benchmark that a lot of LLMs have been evaluated on, and we can generate a different variant of it. For instance, the problem that we just tried, the GSM-8K math problem, up until right now, it's probably we have close to around 4 to 5 variant. Recently, this variant came out called GSM symbolic. What they do is that they they basically create different template out of the problem, and they change the nouns, like the pronouns, but still have the same problem set, but change up some of the nouns and the templates. So that could be a potential way how we can recreate contamination-free benchmarks. Another way we can do is that just maybe do some synthetic data generation to generate a similar set of benchmarks. And then, of course, keep portions private to prevent future leakage. Another one is probe closed models via prompt masking. So I feel like this is a great way to stress test whenever we have new benchmarks and we are evaluating our LLMs, is that we can just try a partial prompt completion to see if the model continues or repeats the full Q&A. So, and another one is obviously like requesting for like a documentation of the report cards, because a lot of LLMs, they come with their report card, but they may not be really sharing about their training data and how they have trained this specific model. So it's we can request this information and ask them to be transparent about it. If not, then there could be other different like models. Especially right now, we have large sets of LLMs coming in. And then, of course, refresh benchmarks regularly, rotating or generating new eval set each cycle to stay ahead of the web trained corpora, especially right now when things are changing quite fast and we have new models coming in quite often. It's important that we also we are also ahead, especially in LLM evaluation. One thing is quite interesting that for each specific task, like the way how we rotate the benchmarks differs. For instance, if we are evaluating the web search models, of course, we need to always upgrade our benchmark set because like we need to ensure that these models that we are evaluating like they're evaluating timely, right? We wanted how good are those web search models in searching recent data. Are they good for real time, or are they just using their training data knowledge to answer those questions? So yeah, it differs depending on like the task that we are solving. Yeah, so it actually leads to our third learning. I feel like I went quite fast. And our final learning as well. So integrating prompt variation and contamination checks into our evaluation pipeline is crucial, and I feel like we should definitely practice this on a large scale level in LLM evaluation. And so our goal always should be that the models that reason, not recall, right? We want the models to share their own true capability, true potential, not just and we need to ensure that our evaluation framework is robust enough for new LLMs that are coming in. Yeah. Thank you.
Sweet. So we have a total of till 4 o'clock for questions. So please take it away with questions, because I'm sure Aziza has lots of expertise and insight.
Thank you. Just a question about the partial, what do you call it, prompt masking or partial prompt completion. I don't think I'd heard of that before. What is that technique, and how does it reveal the memorization?
Yeah, so it's basically whenever we query LLMs with the pretty prominent benchmarks, like for example GSM-8K, we can just maybe start with like a one sentence, and we can see if this specific model continues with the rest of the problem. So if it continues and it gives us correct response, then that means this model might already have knowledge of this GSM-8K, which means it's already trained on. And this test set might not be a good test set for us to use.
Anybody else?
Curious for how you're kind of running these tests. A lot of the individual ones were changes in formatting or small tweaks and stuff. I'm kind of curious, have you found any problems with stability of model performance when it comes to, say, verbosity of a customer's prompt? People have different writing styles and might describe a situation very differently. If there any kind of buckling of that reasoning logic, if they're a little bit more storytelly kind of thing between their prompts, and how you evaluate that difference versus more individualized like YAML versus JSON performances.
Mm-hmm. Yeah. Specifically tested on natural instruction data because it has a lot of different tasks, and especially in enterprise enterprise use cases, we want the model to follow a specific instructions, right? Not like, for instance, not really classify, but we want them to give the right answer. And most of the times, the prompt structure is quite structured, which means like we might request the model to output on a JSON format, or to output like one single letter, or to be specific in terms of numericals. Then across my evaluation of this different variations, I've seen specifically the template result into different responses. For instance, the JSON is always improves the performance because we want to be quite strict in terms of what we want, right? But as we see even from this specific models, this author's research, they even found that, for instance, Markdown could be much more verbose, because in Markdown, we want them to. There's no specific instructions here, as you see, but in JSON, we want them to be much more clear. So similarly, on different variances, like for example, in lexical semantics, I didn't really see a much differentiation. However, you see a quite difference in structural variation, that some of the models, their performance like drastically drops because they may not be really good at like, there's like randomly, I asked them to give JSON in the middle. So, for example, here as well, in reasoning variation, we can easily probe the models in reverse order logic. It's even a bit confusing to human if we just give them this question, right? So similarly for LLMs, they might at first get a little hallucinated, but if we ask them maybe over time and give them more few shot examples, they could be good at it, yeah. But I feel like as a researchers, we look at different ways of how we can trigger LLM, right?
Sweet. Anybody else have any more questions?
Mine was a little lower on the evolutionary scale. So, I mean, for myself, I'm not really good at this. Anyways, you walked past persona a bit. Now, I've always heard that persona is basically used to prime the pump. Have you noticed, have you played with persona at all enough to answer this question? If not, that's fine. Maybe someone else can. But is there a distinction between act as an XYZ or versus, hey, let's talk about statistics? Or even just leaving the persona off at all? I haven't used AI enough to really hone in on it, but it seems to me like most of the time when I do use it, the persona doesn't make much of a difference. But I do tend to naturally go, hey, let's talk about statistics, or hey, let's talk about Python, or let's talk about this, or whatever. And then it doesn't seem to make much of a difference versus act as a Python expert. I don't know.
Yeah, this is just a different variation technique to better understand how would they respond to this kind of prompt. Not specifically like we want them to behave as specific persona, because that's extra tokens, and that's extra cost for us too. That's what we want at the end of the day. We want to find out like best techniques, best variation types that we can use, not only one single, and that could be a potential way to test out if for this specific task, is adding persona good enough or not good enough? I mean, persona could be useful, especially in agentic scenario. We want the LLM to be behaving as a simulator. If not, like it could be as extra cost. Yeah.
Anyone else? All right, perfect. We have plenty of time.
I'm curious on your take when it comes to more productionalized evals. Are there any kind of good opportunity spaces when it comes to, I can't think up what my users are going to input into my model. I never could. Is there any kind of sub-agentic process that might be valuable to add into a productionalized model to run in parallel variants of the same customer question to really stress test based off of real-world scenarios how it handles, instead of my specific customer that I have today is really good at asking in the same format, but I don't know what they'll ask in the style of tomorrow. Like, are there good opportunities to add that in for a real production model to say, let's stress test 5 different variants of a new observation?
Mm-hmm. Yeah, I think that's a great question. So I can think of maybe utilizing a large language model as a judge, but not like any kind of LLMs, but best performing, for instance, GPT-5. We also use as an LLM as a judge model because it's quite best performing, a state-of-the-art model, especially for different sort of tasks currently. And then they could be a much more better than we would fix and integrate a rule-based checks. Especially like we want the model, we don't want to ensure that whatever response we get, we incorrectly label them. We want to label them correctly, and LLM as a judge could really help us to do that. Of course, before integrating, we need to do a lot of evaluations, and depending on our specific like input and output that we're looking for, and we have to do a lot of like maybe a manual review and annotation before integrating into our system to better understand how good is LLM in terms of post-processing the query that user asks, and that way it could be much more robust than like having a very strict rule-based checks. Great, thank you so much.
All right, perfect. Thank you so much for your talk.